In 1943, as the war on the Eastern Front turned into an increasingly brutal struggle of attrition, the German High Command sought a miracle. A weapon so advanced, so powerful, that it would reverse the trend of Soviet industrial growth and battlefield adaptation. Their hope came in the shape of a new tank, the Panther. It was supposed to be the answer to the T-34, the tank that had shocked Germany in 1941 and shattered the illusion of German technical superiority. The Panther was designed as a technological leap forward, a symbol of engineering prowess, a machine meant to restore dominance. But behind the polished metal, behind the beautifully sloped armor and the long, elegant 75mm gun, lay a deeply flawed foundation built on rushed decisions, political interference, poor testing, and an engineering process crippled by unrealistic deadlines and wartime pressures. The Panther, for all its theoretical power, was not ready for war. And the scale of its failure became evident long before the first shot was fired at Kursk, its debut battle. The roots of this failure go back to the summer of 1941, when German troops advancing deep into Soviet territory encountered the T-34 for the first time. German tank crews were stunned. The T-34 combined mobility, armor, and firepower in ways no German tank could match. Its sloped armor rendered many German shells ineffective. Its wide tracks allowed it to traverse terrain where Panzer III and IV struggled. Reports from the front were alarming. German shells bouncing harmlessly, engines overheating from the effort to keep up with the Soviet machines, entire platoons being outrun or outmaneuvered. This shock forced a re-evaluation of Germany's armor doctrine. Hitler, unwilling to accept technological inferiority, demanded a new tank. Not just new, revolutionary. Something that surpassed the T-34 in every measurable aspect. Engineers were given impossible deadlines. Within a year, they were expected to produce a combat-ready tank capable of outperforming anything the Soviets fielded. The normal time required for designing, testing, refining, and calibrating a tank was years. The Panther was given months. What followed was a development process defined by haste and pressure. The design process was chaotic. MAN and Daimler-Benz competed, each offering radically different solutions. Hitler intervened constantly, pushing for heavier armor, bigger guns, and more complex features. The weight of the tank ballooned from the planned 30 tons to over 45 tons. Yet the engine remained roughly the same size. The gearbox, never tested on a machine of that weight, strained under the load. The suspension, although innovative, required precision manufacturing that wartime Germany increasingly could not provide. Factories lacked experienced labor as men were drafted. Material quality declined due to shortages. At every level, the Panther suffered from compromises that undermined its structural integrity. But the pressure to deliver was immense. Germany needed a symbol of technological superiority. Kursk was approaching, and Hitler wanted the Panther on the battlefield, regardless of whether it was ready. By early 1943, the first Panthers began arriving at the Eastern Front. They looked impressive, sleek, modern, menacing. Crews were excited to receive what propaganda called the most advanced tank in the world. But the excitement faded quickly. Before Operation Citadel began, before Soviet defenses were even engaged, the Panthers revealed their hidden flaws. In the weeks leading up to Kursk, approximately 45 of the 200 Panthers assigned to XLVII Panzer Corps broke down before ever reaching the line of departure. These failures were not caused by enemy fire. They were mechanical collapses, engines that overheated and ignited, gearboxes that seized, final drive gears that shattered under normal driving, fuel pumps that burst without warning, oil systems that leaked uncontrollably. The Panther was a machine that fought itself more than it fought the enemy. Field reports were grim. Engineers documented engine fires caused by poor sealing and inadequate cooling. Some Panthers simply burst into flames during training maneuvers. Others overheated after 10 or 15 minutes of driving. The gearbox, the AK-7-200, was completely inadequate for a 45-ton tank. It had been designed for lighter vehicles. Panther crews wrote in frustration that every kilometer risked a breakdown. Mechanics worked endlessly, cannibalizing parts from other Panthers just to keep a fraction of the force mobile. The situation became so dire that in June 1943, days before the offensive, senior commanders warned that the entire Panther Brigade was at risk of becoming non-operational before the first battle began. On July 5, 1943, the Battle of Kursk commenced, and the Panthers finally entered combat. The result was catastrophic. Many tanks broke down even as they attempted to form up. Heat, dust, and stress on untested components caused widespread failures. Some Panthers caught fire while idling. Others lost mobility after minor terrain obstacles. By midday, dozens of Panthers lay immobilized behind German lines. When German forces attempted to push through Soviet defenses, the Panthers often lagged behind, forced to stop for emergency repairs. Their presence was supposed to spearhead the assault, but instead, they became logistical burdens, obstructing the advance and drawing resources away from maneuver units. Some Panthers that did reach the battlefield performed well in frontal engagements, using their powerful 75mm gun effectively. But their numbers were too few, and their reliability too poor, to influence the battle decisively. By the end of the first day, only about 40 out of nearly 200 Panthers remained combat ready. Crew diaries describe a sense of despair. Soldiers wrote that mechanical breakdowns were more feared than enemy fire. The Panther's crew compartment was cramped and difficult to escape during fires. Many Panthers burned not because of Soviet shells, but because of their own engines. Field commanders complained that Panthers required hours of maintenance for every hour of driving. Ammunition elevators jammed. Electrical systems malfunctioned. Fuel lines leaked profusely. Hydraulic components failed under heat. Even when repaired, these tanks often broke down again after a few kilometers. Hitler demanded explanations, and Guderian, after reviewing the situation firsthand, delivered one of his most damning assessments: "The Panther is not fit for combat. It is a premature birth." After Kursk, frantic efforts were made to improve the Panther. Factories introduced dozens of fixes: stronger final drives, modified cooling systems, improved seals, reinforced suspension components. Some modifications helped, many did not. Wartime pressures meant shortcuts were inevitable. Workers were untrained, steel quality inconsistent, oversight reduced. The Panther remained a tank with exceptional theoretical capabilities but persistent practical flaws. It consumed enormous amounts of fuel, strained transport networks, required specialized recovery vehicles, and demanded constant maintenance. Germany, already losing the industrial war, could not afford such a temperamental machine. By 1944, later Panther versions performed better, but they never achieved true reliability. They remained dangerous to the enemy but equally dangerous to their own crews. They forced Germany to invest resources disproportionate to their battlefield value. The myth of the Panther as a perfect killing machine comes largely from post-war admiration of its design concepts, not its wartime performance. The historical record tells a different story. A tank rushed into existence, crippled by poor engineering decisions, and deployed before it was ready, a machine that consistently failed itself before the enemy had a chance to. A weapon Germany desperately needed but could never truly master. The Panther stands today as one of the clearest examples of how overambition, political pressure, and unrealistic expectations can sabotage even the most impressive engineering projects. On paper, it was a masterpiece. In reality, it was a mechanical tragedy.